Hello all, in today's video we are going to cover the topic that is the pumping lemma. Pumping lemma is very much important in G2 exam as well. First of all, what is pumping lemma? The pumping lemma is always used to prove that your language is not regular. So if your language is regular, that means there must be an FA for accepting that language, and if your language is not regular, that means FA will not be there to accept that string. So how you will prove whether your string or your language is regular or not? That can be proved within the pumping lemma. So we will do it. First of all, you have to remember some of the rules of the pumping lemma. Pumping lemma, why we are using? See, in your exams, the questions will not be many times directly asked like apply the pumping lemma. But any question is given to you and prove. Like question will be like prove the language is not regular, or prove whether the language is regular or not. So you have to understood your own self that you have to apply here the pumping lemma theorem. Okay, so first of all, why the pumping lemma we are using? It is to prove your language is not regular. Okay, so 3 steps you have to follow. You have to remember these steps because there is a theorem given for that. The very first step is you have to assume your language is regular. See here, as 2 methods will be there to satisfaction of any statement, contradiction and contrapositive. Here we will apply the second, that is the contradiction method. That means if we have to prove our language is not regular, we will take a reverse of that. That means first we will assume it is regular, and by the theorem steps we will prove whatever we have assumed was wrong. Okay, so here first step we will do is we will assume that it is regular and FA is there. That means whatever language we are trying to prove is not regular, first we will assume it is regular and FA will be there for the same. Second step is we will choose any language, that is W. W, don't be confused here, it is belongs to the language. So what is written here, W is an any string. As we have discussed, the modular of W, that will be a length. So whenever you are given a modulo, don't consider it as an absolute, it will be a length of the string. Okay, so your W is any language that belongs to the language, so module of W, that will be a length, and it will be always greater or equals to n. That means something will be there, some string will be stored in the W. Okay, the third step is very much important. You have to take your W in the form of x, y and z. That means the third part, 3 parts will be there of your string. The very first is string length of xy. That means the first 2 parts will be always less than or equals to n. This step indicate that if your length is on a string length n and W has also length n, that means the z can be 0. Null string can be there in the z stored. The second important step is the length of the y will be always greater than 0. That means it is indicating that in your main string the middle intermediate part can never be a 0. That is of 0 length string. Okay, now once we are declaring x, y and y, and after that we have to take some I is an any constant, but how you have to take it, it is very much important. Then you have to follow the step x, y belongs to I and z, and we will prove it is not belonging to the L. That means whatever we have assumed, this is in contradiction, so L is not regular. If you are not clear with this steps, don't be confused because we are going to solve 2 examples, so it will be more clear to you. Just take the first example. The question is given like a way, L is an a raised to n and b raised to n. Just prove it, it is not the regular. It is not given here that you have to prove with the pumping lemma, but you have to by default understood that this here we have to prove it is not regular. That means you have to apply the pumping lemma theorem. Okay, so as discussed, 3 steps we have to do. Just an overview. The very first step we have to assume it is regular. The second step, choose in W like a way, it has some length. And third is you have to divide your string in 3 parts, x, y and z. The length of y must be compulsory greater than 0. xy can have less than or equals to n length, and you have to select some I, and you have to prove x, y raised to z, y raised to I, z does not belongs to L. Okay, so one by one we will do all the 3 steps. The very first is a raised to n, b raised to n. So step 1 is we will assume it is regular by the FA, and FA have n states. Okay, so here we are assuming that it is regular. If the language is regular, that means the FA must be there for that. The second step is the language whatever is given to you, it will be in the form of W. That means here our W is a raised to n and b raised to n. Now in this, the length, see here, first have occurrences n, second have occurrences n. That means if we are finding the length of the string n plus n, that will be equals to 2n. That means compulsory the situation is followed here. It is greater or equals to n, because n plus n will be 2n, so obvious it is greater or equals to n. So here our w will be in the form of xyz. So w will be in the form of xyz. These are the theorem rules from the theorem that y should be compulsory greater than 0 and xy can have a less than or equals to n. Now here the main and important part is you have to select the x and y like a way that these two rules should be compulsory followed. Always remember these two are the most important rules. The very first is x, y should be less than or equals to n. The second is modulo y should be greater than or equals to 0. Okay. So here suppose for the sake of simplicity, see, always try to take a string. That means if you are dividing your string in the form of x and y, so always try to take from the first part of the string only, because it will be easier for you to prove whether this string is not the regular language. So here for the simplicity we are taking y is any a raised to I. Why we have taken a raised to I? Because the first part of a main string is a raised to n. That means from n, suppose we are taking any power, that is r. But the second rule of the pumping lemma is compulsory indicating y, the length of y should be greater than 0. That means here we have to satisfy compulsory the value of r should be greater than 0. Here you can write this from the theorem, because from the theorem only we have to take that r should be greater than 0. Okay, and x and e we are taking as an a raised to s. So here we are not providing any condition for the s, like s should be greater than 0 or s should be greater or equals to 1 or anything, because it is not given to us. S can be any power. So once we are declaring overall string, that is a raised to n and b raised to n. That means, and now a raised to n and b raised to n is also in the form of x, y, z. So here our x is a raised to s. So first we are declaring a raised to s. Then we are declaring the y string, that y here we are taking as a raised to r. Now we have to overall get the final string, that is a raised to n and b raised to n. So a raised to s and a raised to r already we have taken. So what are the remaining powers of a is remaining? See, total a has n numbers. Here we have already taken s and r. This is x, this is y. So how many number of occurrences of a are remaining now? So it is a raised to n minus s and minus r. What is the reason for that? Because a raised to s already we have taken in x form, a raised to r we have already taken in the y form. So the remaining will be a raised to n minus s minus r, and b raised to n will be as it is. So here it is x, it is y, and the remaining part of the string is z. Okay, now move on to the next step, that is the I. Take any of the I. Now we have to do x, y raised to I and z, and we have to prove it is not belonging to our language, that is already given in the question. Suppose for the sake of simplicity we are taking it as an I2. I you can take any value 2, 3, 4. If the condition is given like I greater than 0, I greater than 1, so accordingly you have to take here for the simplicity we are taking I equals to 2. So x, y raised to I z does not belongs to L, that we have to prove. So we are taking x, y in place of I here we are taking 2. So x, y square z. X we have to use a raised to s, y that is a raised to r. Here we are taking square. So again we are taking square, and z whatever remaining part will be there as it is. So a raised to s, a raised to r raised to 2, that means it will be 2r. Z will be as it is. Just do the simplification. Base is same, so you have to do the addition and subtraction of the powers, because according to the rule of mathematics, base is same, that you can do the summation or subtraction of the powers. So a s plus 2r plus n minus s minus r. So s and s going to cut, 2r minus r will be r and n. So a raised to r plus n will be remaining, and b raised to n. But from our law, that is we have already taken the condition r is greater than 0. Here you can give it as an formula number 1. This is as a formula number 2. So from formula number 1, from equation 1, we have compulsory r greater than 0. So r is greater than 0, that means a has power r plus n and b has r. That means a have some occurrences are greater than the b, but according to our language given, a and b must have the same number of occurrences. That means here since r is greater than 0, so the number of a's are more. So we have proved it is not the regular language. Hope it's clear to know you. One more example we are taking, so it will be more clear to you, and this is the most important actually question. So in your exam, the question may be asked like a way, prove the pumping lemma for w and w raised to r, where w will be in the form of 0, 1, or it may be given w will be in the form of a, b, whatever will be given. What is w raised to r? See here, w is any of the string, and w raised to r is indicating of the reverse of the string. Reverse of string, okay, because r in the w raised to r, that means it is the reverse of the w. So ultimately this is the same question that you have to prove for the palindrome of the string. So in your GTO exam the question may be asked like prove the pumping lemma for the palindrome string. See, just take an example, w and w raised to r. Suppose w we are taking ab, so w raised to r will be ba, that means it is an palindrome abba. Okay, so question may be asked like a way w raised to r, or it will be asked like a way that the palindrome. So very first step, assume it is regular. Second, w will be taken. Here we are given, suppose w will be in the form of ab, so here we are taking a raised to b, that will be w. So w raised to r will be b, a raised to b, a raised to n. Okay, whatever will be the original string, and reverse of that will be w raised to r. The length of the string will be n plus 1 plus 1 plus n, that means 2n plus 2. It is obvious, greater than or equals to 0. These are the two rules of the pumping lemma. So here, for the sake of simplicity, as we have already discussed, first part will be divided, so it will be easier for you to prove. So suppose we are taking x will be the first is a raised to n, that means a raised to s we are taking, y again same we are taking a raised to r, and r should be greater than 0 according to the theorem that is given to us. Okay, so w will be in the form of x, y, z. Here a raised to n, b raised to n. So in the form of x, y, z, first a raised to s will be x, a raised to r will be r. So we have to make the overall occurrences of a will be n. So it will be remaining will be n minus s minus r, and the remaining string as it is. So this will be s. Now the third step, we have to take this value of I suppose here we are taking 2. So again x, y square z. X will be a raised to s, y will be a raised to r, and square will be there. And the z, the whatever remaining string as it is, just do the simplification, r square, that means 2r, again the same base, so powers we have to subtract and do the addition, s plus 2r, my plus s minus r, plus and minus s will be cut down, 2r minus r will be r, and plus n remaining. So here, since we have already declared r is greater than 0, that means r must